Hello, ladies and gentlemen. I would like to introduce to you one of the very important plots that we normally encounter in statistics, and this is the box and whisker plot. It was introduced by J.W. Tukey. The box and whisker plot, as well as the stem and leaf, they were both introduced by Tukey. We have already seen the stem and leaf before. And we are going to work on the box and whisker plot using an example. We refer to this example as the airline seats sold data. It is something that is also appearing in other contexts. So on a linear scale, you look at the figure in the next slide. You make vertical marks corresponding to the minimum, the first quarter, the median, the third quarter, and the maximum. So this data, the air and seats data, we have already seen this one when we are looking at the quartile, semi-quartile deviation. So we already had these quantities, 67, 78, 93, 100. We know these quantities. But what we want to do, I will then move to the plot, is that we make vertical lines. So for this line here, which is standing for the first quarter, the line for the minimum, the line for the median. So basically, we know the minimum is 54. So this line here, if you look at, if you have a horizontal line marking from 50 to 100, we decided to start from 50 because we know there are no values below 54. So starting from 50 would be a fair range of the scale, 50 to 100. So this is 54, and then we have 67, and then we have 78 as the median. Then we have 93 as the third quarter, and the maximum is 100. So that was the moment when all the 100 seats in the airline, in the craft, were sold. Then the lines for the first and third quarter are joined to make a box corresponding to the central 50% of the observations. So what happens, the first and third quarter, now we make this rectangular box. So you join this, and these ones represent 50% of the data, because we know from first quarter, it's 25% of the data points of observation lie below this first quarter. Then 50% of the data lie below the median or the second quarter. 75% of the data lie below the third quarter. Now, if we take the first and third quarter, so 50% of the data lie here, because we know 25% lie above the third quarter. So 25 and 25 below is another 50. And so you draw a box, and the whiskers are taken out from the box to the maximum and minimum values. So you take, you join, you draw whiskers from here. These are whiskers, more or less like the whiskers for a cat. That's why it's referred to as a box and whisker plot. So you draw the box and then the whiskers to the minimum and the whiskers to the maximum. Now, After that, so this is often a convenient way of representing a distribution and is particularly useful for comparing distributions. So you can compare distributions looking at how the spread is looking like in the box and whisker plot. So the figure now that we have here is the box and whisker plot for the airline seats sold data. The next concept that I would like to us to look at is the concept of quantiles. Now we looked at quartiles, but you'll discover that quartiles are basically a subset of quantiles. So quantiles, it's a generalization. So if we have a very large mass of data, we might want to divide it into more than 4 parts to make a summary of it. So 4 parts, those are the quartiles that we have seen, that you have a data point where 25% of the data is lying below it. And then you have median, 50% lying below the median. You have the third quartile where 75% of the data lies below the third quartile. And then you have these 4 divisions of your data set. But you may need to do more than 4 divisions, more than 4 parts. It is often helpful to draw a cumulative frequency curve, that is to plot the cumulative frequency in the vertical direction against increasing values of the variable plotted horizontally. Such a curve is often called ogive to describe its general shape. From this, required results can be read, and we'll see an example later. So the median, the quartiles divide a set of ranked observations into 4 parts. So the median divides into 2 parts, the quartiles into 4 parts. And then the other sets of measures, we have the deciles and the percentiles. So the deciles divide the set of observations into 10 parts. So you have 10 data point where 10% of the data falls below it. You have another data point where 20% of the data falls below it, and 30%, 40%, 50%, which will be the median basically. Then 60%, 70, 80, 90%, up to 100. So you have 10 divisions. So if you have deciles and you want a median, basically you'll be looking at the number 5 one. So the 5th decile, that will be corresponding to the median. Percentiles, on the other hand, these divide the data into 100 parts. So you have 1%, you have 2%, 3%, 4% of the data lying below that point, 5% of the data lying below that point, and you have 25%. Now, when you reach 25%, that will be the same as the first quartile. You reach 50%, that would be like the median. 75%, that would be the same as the third quartile, up to 100%. So these divide the data into 100 parts. And in general, then you refer these to as quantiles. So the number, how many you want, in general, these will be not necessarily decile or percentile, they will be quantiles. So quantiles is a general term in terms of how many parts you can divide your set of observations into. So I think I've already said this. So deciles, the deciles of a set of ranked observations on a variable are variable values which divide the set into 10 equal parts. Percentiles, the percentiles of a set of ranked observations on a variable are the variable values which divide the set into 100 equal parts. More generally, we can consider measures which divide the set of ranked observations into Q parts. One of these measures will be the pth qutile where P takes one of the values 1, 2, up to Q minus 1. Thus the quartiles Q is equal to 4, and then P is 1, 2, 3, so which stands for the first quartile, second quartile, which is basically the median, and the third quartile. The general term for these measures is quantiles. The quartiles, deciles, and percentiles are just a subset of that. Okay, so next time I will look at an example, and let me stop here for this. So the box and whisker plot, how is it generated? It's from the same ranked data, and you have your quartiles. You draw a box which ranges from the first quartile to the third quartile, and then you extend lines, the whiskers, from the third quartile going upwards, the maximum from the first quartile going downwards to the minimum. So that's how you draw a box and whisker plot. And then we have discussed in general what quantiles are all about. Thank you for now. I'll proceed later with an example when I come again.